Hello, this is Scholar Strife. Welcome back. This is Geometry section 4.3. In the last section, we figured out how to prove two triangles are congruent. We had to show that all corresponding sides and all corresponding angles were congruent. So we had to find 6 different things. In today's lesson, we're going to show you one shortcut that we can use, and it's called the SSS, or side-side-side congruence postulate. And what it says is, if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So they have AB congruent to SR, BC congruent to ST, and then AC congruent to RT. That means the 2 triangles are congruent. And then after you can say that the 2 triangles are congruent, you can say the corresponding angles are congruent. Let's look at an example proof here. Pretty quick, easy, kind of 3-stepper. In step 1, you would write your statement: KL is congruent to NL, KM is congruent to NM, and that's because that's congruent. 1 is given. And then in step 2, so let's erase this little line here. So this would be 1, 2. I would say LM is congruent to LM. Because remember, when we're trying to show 2 triangles are congruent now, all we need to show is the 3 sides. So we have one side, second side, and then we need to show the third side. Since they share the same side, we can say that LM is congruent to itself, and that is the reflexive property. And now finally, or we can use our shortcut, SSS. Also written down here, just in case you want the wording there. So that was a quick one. And it'll show up in your worksheet for tonight. Next. Okay, so in this next example, we want to determine whether triangle ABC is congruent to DEF. In order to show that, and then they give us a list of points in a grid. So first thing I'm going to do is graph these. Now this is something you don't have to do, but sometimes it makes it easier if you can see all the points. So A is 1, 2, so that's right here. B is 4, -3, so 1, 2, 3, 4, -3, 1, 2, 3, 2, 5. So 1, 2, 3, 4, 5, and then I'm going to connect my 3 dots here. This represents A, B, C. I didn't draw that right, but whoops. That is the triangle. And then we're going to draw another triangle here, 4, 7, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So this is D. E is 7 over 7, 2. So 5, 6, 7, 1, 2. Oh. Let me make my dot. Wait. 4, 5, 6, 7. Sorry. It's right here. Let's erase that. Okay, and then lastly 5, 10. So back up 2, and then we're gonna go 8, 9, 10. So one way to look at this. Oh wait, that's E, That was F. Okay. And then hopefully this will let me draw, please. There we go. So if I drew it correctly, you would tell that they look very similar. And one way to look at it is we're trying to find the distance of each of these, and hopefully they match. One thing you could do is if they're rotated the same way, I can start from A to C. A to C, I go right 1, up 3. So from A to C, I go right 1, up 3. From D to F, I go right 1, up 3. So that's the same thing. From A to B, I go down 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Wait. Sorry. 1, 2, 3, 4, 5. And then over 2. For D to E, I go 1, 2, 3, 4, 5 over 3. So that means these are not going to be the same. The other way to look at it is to use the distance formula. So distance equals the square root of x2 minus x1 squared plus my y values, y2 minus y1 squared. And then we already know that a to b and d to e it's not going to work, so I'll show that example. So a to b would equal the square root of -3 minus 2 squared plus 4 minus 1 squared. And I'm getting these coordinates from the left side here, x, y. So this would be the same thing as -5 squared plus 3 squared. So that's equal to 25 plus 9, which is equal to 34, square root of 34. DE would be the square root of (7 minus 4) squared plus 2 minus 7 squared. And what I just found out is that I graphed it wrong, because 3 squared plus 5 squared is the square root of 34. So these match. So what did I do wrong here? E is 7, 2. D was 4, 7. A was, so B was 4, -3. 1. That's where I went wrong. So B is actually supposed to be right here. So A, C was 2, 5. B was 1, 2, 3, 4. 1, 2, 3. All right. Okay. So, back to the picture way. So, A to C, once again, was right 1, up 3. D to F, right 1, up 3. A to B is the same to E. So let's check C to B and E to F. So C to B is down 1, 2, 3, 4, 5, 6, 7, 8 over 2. From F to E, 1, 2, 3, 4, 5, 6, 7, 8 over 2. So those will all be the same. If I did the distance formulas, they would all have corresponding distances would be the same. And that's one way to prove that two triangles are congruent. If for whatever reason you find that the two corresponding sides don't equal, So for example, if this was actually square root of 35, and that was square root of 34, then you can say these two triangles aren't the same. You don't have to do the rest of the problem, because all you need to do is find one pair to show that they are not congruent. But to show that they are congruent, all these points, or all these segments, need to be the same. Or these three pairs need to be the same. This pair, so pair 1 and 2, pair 1, pair 2, and pair 3. Alright, hopefully that wasn't too confusing. And that's it. Your worksheet should... Oh, wait, there's one more thing. Talking about stability. So this kind of works well in construction, but basically in math, well, in engineering, if we have a structure, let's say this is a box, it's stable if we have a diagonal. If it doesn't have a diagonal, it's not stable. So let's draw a little house here with a roof. Now the roof itself is diagonal, but pretend pouring snow on it. It gets heavier and heavier and heavier. The roof will cave in and snow will fall on your house. So in order to make that stable, you would have diagonals or, braces, right? Triangles. If you make triangles, you build stronger structures. And then you'll probably notice this, but this is coming from your worksheet anyways. The last one, we have this thing going on. This is also stable. So stable. The original wasn't stable, but now it is, and then stable. Alright. I think that's it. Work on your worksheet and have a good day.